Thank you very much for attending this ARTSOUNDSCAPES seminar. And I'm going to first present the project and the speaker. The project is an ERC project that started in 2018, so it should have finished by now, but because of COVID, we asked and obtained the permission to continue for one more year. So we are now in our last year of the project. As you may know, some of you definitely know because you are in the project, some others perhaps you are not that familiar with this is a project that has several research lines. It is based on rock art, so I am an archaeologist, and the archaeological basis is rock art. In fact, in the application, I said five research lines, but didn't include rock art. So that's why it is the last one, which we now call research line 0. But anyway, the first one was physical acoustics, characterizing the acoustic properties of rock art landscapes. Then we have a research line 2 that was psychoacoustics, the psychoacoustics of rock art. The third one that was neuropsychology, the acoustics or neuroacoustics, if you want. Then we had another one of anthropology, ethnology. So of looking at information in the anthropological sources, ethnographical sources. And then the fifth one was putting everything together, really. Looking at how all that could combine. So here it says the analysis of sacred emotion in rock art soundscapes. Right, in fact, we have been working in all those research lines. Let me give you some highlights of the ARTSOUNDSCAPES project, because we started organizing many seminars at the start. So that was one of the ways in which all these research lines could combine, and we understood what all the others were talking. But in the last in the last couple of years, we have organized several seminars, and media has been very active in this, but not as many as we used to. So what has happened? We have a Ph.D. recently thesis, I should say, that submitted early this week. So we are really delighted with this in the psychoacoustics of rock art, of rock art landscapes. Then she will be moving now to a postdoc position. Then Nehemias was successful in a Marie Curie application, and is now in Bordeaux, in New Lands. We have 2 new researchers, that is Natalia here and Joshua. Natalia working on Mexico and the rock art landscapes of Mexico, and Joshua musical instruments in Southern Africa. We, of course, haven't included her here because, we have also Sorana Dobrevich, who is a Marie Curie working on medieval, that's Sorana, say hello, medieval monastery landscapes. And then, we were, 2023, we did tons of, we successfully published many different things. So, you can see how in the end everything worked out, and it was really successful in terms of publications. And have also a look at our blogs. I think it's fun to know what is going on in the project, really. So at the moment, these are the ones who are here, who are in the project, although Samantha is in fact has now moved to her new postdoc, but that's let me go to the next one. And so let's see then our finally we arrived to our speaker, Brian. Right, Brian, I think that half of these, people, audience know exactly who Brian is, the other ones probably as well. One of the most renowned international specialists in acoustical measurements and analysis and virtual reality simulations. Background in physics and philosophy. Wow, I didn't know that. So the VI was also included philosophy, but then he moved to definitely acoustics in Penn State University. He was working in the US and then moved to Europe about the turn of the century, and has been working as a consultant and then now in the CNRS. And he now leads this SoundScapes research team at the CNRS. And as he will be talking to us about part of the research that he's leading there. He investigates spatial 3D audio rendering and perception, room acoustics, HCI, which you will tell me now.
Human computer interfaces.
Okay, great. Virtual reality applications to acoustic cultural heritage, and is a fellow of the Acoustical Society of America. Then, if this moves, right? So today, I had this one. He is successful in many projects. If you go to that webpage, you will see the amount of projects that his research team is running. It's absolutely impressive. Anyway, so we have the honor of having him here today to talk about experimental virtual archaeological acoustics, bringing together physical, computer, and social science researchers. And the idea of the question is how human-to-human communication worked in historical contexts. That's what he's going to try to answer, and try to convince us that computational acoustic simulations can help to answer this question with virtual reality tools. How doing, for example, live performances in virtual historical venues. If I am incorrect, he will tell us later on. But so virtual reality modeling allows two types of different things that I think is a key, what he's going to tell us about. First, research, and then public communication and artistic projects. So research, what is the impact of this acoustic variation on performance and listener interpretation, in particular historical periods. And regarding public communication is how virtual performances can help these communications, cinematic reconstruction, podcast, musicographic installations. So anyway, so the floor is yours, Brian, and now it would be fantastic to listen to know what you have to tell us. So I will stop sharing and allow you to then share your PowerPoint. So thank you very much. And then
there we go.
Yeah.
Not bad.
Yeah.
Okay. Thank you very much for coming. Thank you very much for inviting me. The date's wrong because I think it was when the seminar was supposed to be before we moved it.
Yeah.
It's very weird seeing my own slides up before, but we'll try to do that. So what I want to do is more of an overview of some of the different projects that we've been doing that have kind of touched on social science research, history research, to give you an idea and hopefully spur some discussion more than explaining in detail how anything has been done. So, well, I don't need to go into the detail of who I am because Margarita already presented who I am. But the key bits are kind of what my core research has been in, and it's in spatial hearing and psychoacoustics. So really, how do we hear where sounds are coming from? Room acoustics in terms of measurements and simulations. And then in the context of virtual reality, looking at interactive scenarios in audio and spatial audio. We've done some research on spatial auditory navigation and simulations for the blind. And the most recent kind of big direction that I've been working on is in this cultural heritage, historical acoustic simulations. And kind of how I like to begin in the beginning is, so room acoustics already on its own is an interdisciplinary subject. So we look at the physics of the building, we can look at the psychoacoustics of what it's like to be in the space. It also impacts music and architecture. If we now look at the heritage aspects, then we also bring in historians, art historians, musicologists, archaeologists, and sociologists to see how those all interact. And if we look specifically kind of at music and music performance, there's already kind of a direction of research in musicology called historically informed performance, where musicians try to use historic instruments or historic reproductions of instruments and try to perform as they did at the time to recreate those pieces of music. But very little has really been looked at the spaces where they're playing. So you can have a historically informed performance in a 1960s concert hall. And so some of the questions we've been asking are, well, if you actually did that same performance in the building that it was intended, would the music actually change? So that kind of brings us into that idea of looking at the acoustics of performance or the acoustic spaces of human communication and how do those impact those communications. And then, so basically, and now I'm assuming everybody here knows this idea. So the acoustics of a space is kind of the intangible result of all of the tangible physical decisions in making a building. The room acoustics impacts, affects, and completes any sound that's made inside that space. And kind of the same way if I'm doing graphic visualizations, if there's no light source in my visualization, I don't see anything. If there's no sound source in my acoustic simulation, there's nothing to listen to. So we'll kind of get into what sounds you put into spaces when you're kind of evaluating them. This is a small little exercise that I like to do. So this is kind of giving the main characteristic that we use to quantify the acoustics inside spaces is the reverberation time. And this is just to give you an idea of the same sound under different reverberation conditions. And I want you to think about what is the best reverberation. What do you think is the best reverberation in this condition? So it'll play with kind of 0, 1, 3, and 6 as a reverb time. I took a general poll, which one do you think, or which one do you find is the best reverberation time? This one?
Yeah, one.
No.
One?
Well, one or two.
One, I think.
I
I
like
don't know why that came up.
I like
Which one?
the trial one.
The zero?
Yeah.
So the zero to me
One.
sounds like like an accordion.
Yeah.
I
think.
And
1, 3. 3 sounds like a cathedral.
yeah, and 6.
And 6 like a cathedral with very bad acoustics.
But you're far away from the source.
Yeah, so and if you so yeah, 3 is kind of the one that most people kind of tend, somewhere between 1 and 3 depending on the piece of music. So we did tests with kind of the same acoustics but different pieces of music. So on the same organ playing a more modern, very kind of conceptual piece, then people preferred 0 or 1. And then if you play something very long, very kind of traditional for an organ, then it can work at 6. And if you repeat the same thing, for example, with speech, you don't get it all the same. So the idea is just to think that the notion of best acoustics is very context dependent.
In the chat,
Oh, there's
they said 3, 3, 3, then someone 0, and then someone, no, Lydia says 6 is a mess.
yeah. And if you look at kind of big Gothic cathedrals, we're up at like 9 and 10. Right? So Notre-Dame is 10 to 12, as an example. So but nobody says, "Ooh, the acoustics is terribly stable state in public." So it's just think in terms of the context of the acoustics and avoid this idea of what is the ideal reverberation time. It's kind of the idea. Right, there we go. So how do we study the acoustics of a space? And I think everybody here kind of already gets that idea. So we can do modeling and numerical simulation. So we can look at the impact of form and material on different spaces. We can also do measurements inside spaces, which the team here has done a lot of. And that gives you a way to kind of quantify the acoustics of the moment, to kind of take a snapshot of it. But it also lets you calibrate your acoustic model. So if I make an acoustic model of today, and then I do a measurement of today, then I have confidence in the model, and then I can start playing with the model and change it to different parts. Puritan history, you want me to just, there we go. I'll let people in when.
Yeah,
So with numerical simulations, right, we can look at kind of the impact of specific propagation effects, look at the impact of different kind of, here it's looking at reflectors. Here it's looking at the impact of some diffracting elements up on the ceiling. And we can do simulations in 2D and we can do simulations in 3D. Well, it's important to, it's not only the geometry, but we have to know what the materials are. And we have to know a lot of the times what the materials are constructed of. So you can't just say, ooh, this wall is wood, because it could be 1 millimeter of plywood, or it could be, 10 centimeters of solid oak. And those aren't going to have the same acoustic conditions. So it's not just a visual inspection. Usually we need to know a bit more about what's behind it, and how things are, I don't know. That should kind of go away on it.
yeah.
What do we teach you? Sorry.
I think if I don't touch it for a little while, it'll go away.
If you.
Okay. Now it's going for good.
No, let's see.
That's fine.
Because it does too.
So some of the examples that we've been doing recently to try and categorize the acoustics of historic materials, because a lot of the databases don't really have those, was to go to a couple of museums and kind of textile archives and look at some textiles from the Middle Ages, from the Baroque period. So we did a series at the Louvre with in collaboration with Angelo Farina's team in Italy. We went to kind of the national furniture storage and got some curtains. And this is a huge carpet that actually covers the whole choir section of Notre Dame. It only comes out every 50, 100 years. And it luckily was being restored during the fire. So it kind of got saved with that because they found it had bugs in it. So they took it out. So now it's in a big state of restoration because the hope is to bring it back for part of the opening. But in this giant hangar, we were able to get access and do some measurements on it as well. So how do we kind of experience these kind of room acoustic simulations? So this is kind of an approach that we've been using. So we can have dry recordings of sound sources in anechoic rooms. We have our computer simulation, which is an offline calculation. Then we can convolve these two and create the acoustic impression. We have a visual rendering, which is usually more detailed than the acoustic rendering. And then through some kind of real-time, usually game engines, then we can actually link these two all together, and then we're allowed to move around and see and hear at different places in the environment. But kind of before using all of these computer simulations in scientific study, I kind of have broken down into kind of 3 levels of confidence that I think we should have before actually using them in science. So the first is, can we trust the acoustic fidelity of our simulations? And that basically means if I measure something in reality and I measure something inside the computer simulation, do I get the same thing? And then I can look at it as more of an auditory level. So if I give you 2 recordings, one is made in the simulation and one is made in the real space, do I hear the same thing? And the last one is, can I make a convincing immersive environment, which is really looking at human behavior. So if I stick you into a historic place and I let you sing or speak, and then I put you into the computer simulation, you behave the same way. So that's kind of the progression of how I think we need to have kind of very high quality simulations to actually do acoustic science with them, as opposed to doing a museum exhibit or something kind of for the general public. Oops. Am I going the wrong way?
Perhaps.
Do I need the thing back again? There we go. I don't know what I did, but
Perhaps.
no, I think that brings up like a menu. If I So the way to kind of test those different levels, we kind of came up with a methodology for calibrating models and creating models. We did a test on 3 different rooms. So we have a kind of small Italian style opera house, theater, a small cathedral, and then the large Notre-Dame Cathedral. We did measurements all over in each of them, created computer models. Here we have the kind of the measurement side.
Hello, can you hear us?
Yes. Is that better now?
Oh, yeah, it's coming back. Sorry, please continue.
So here you can see in the 3 different rooms, kind of the quality that we're able to get in terms of the simulations. Okay.
Yeah.
So in the center line, you can have the average of the measurements. The little gray bars are the perceptual variance that we can notice, I think, or the standard deviation. And then the ones with the dots are what we're able to do with the computer simulations. So we're able to kind of reproduce quite well the local room acoustics in all of those spaces. And then the next idea is actually to compare with a listening test. So we can take the measurements in the spaces, the simulations in the spaces, and then have people listen to different productions in each of those and judge, for example, which one is more reverberant, which one has a higher clarity, sense of distance, tonal balance, coloration, plausibility, apparent source width, which is kind of how big a sound source sounds, and the sense of envelopment. And doing this as a big blind study and comparing between the measured and the simulated, we see that we're pretty much 50-50 between all of these parameters. So we can have confidence on these questions that the simulations are just as good as the reality, which means we can now start modifying those historical simulations. Here I can give an example. We'll see how it sounds on this. I think this is the one that sounds not very loud, so I need to turn this up. So this is a concert recording inside Notre-Dame. The microphone sitting over the conductor's position, and you'll hear kind of a 30-second extract of an orchestra performance. And then we can switch to the simulation version with the microphones in the exact same place, with all the same musicians playing the exact same thing, but in the virtual space. And the idea is to kind of see how similar do you find the two. And let's see if I can do this. People at home have it easier because they can be wearing headphones, because this is meant to be in binaural. But hopefully, sure if it comes across very well on these speakers.
Reconstructed was better. It sounded better.
It can't be better because that's real.
Yeah.
So it can be.
Okay.
It can be clearer.
Clear. Yeah.
And that was one of the things that I think our impression of, at least on that one, was that the vocalist who's singing 2 meters to the left of the conductor has a higher clarity in the simulation than in the real. And then we worked on things afterwards, but that's the general impression. There we go. So one of the things that.
Sorry, may I ask you something?
Sure.
When you did the
Anytime.
when you did the no, the virtual thing, did you first have like a dry recording and then, or?
So for that concert, it was recorded by the National Conservatory with kind of semi close miking of the musicians in Notre-Dame. So what you hear in the real one is actually just sitting at the choir's position during the performance. And then the virtual version is taking the microphone recordings at each of the instrument groups and then putting those into the room. So it's not perfectly dry. But I think other than a little bleed through between neighboring microphones, it works, I think works pretty well. The worst is the kettle drum, because when the kettle drum goes really loud, all of the microphones pick it up. So then you get a real change in the sense of how big the kettle drum is between the two. But for example, all the singers, I think the singers were wearing head microphones. And I think each section of the orchestra had a microphone. So there was like 45 microphones.
Lydia commented that the sound with the headphones, the sound, both of the examples were very similar.
That's the goal. So one of the things that we notice is kind of what's important is the directivity of the instruments, and even more so the directivity of the voice. And that's probably why it was more clear. So we've been doing some work on fine analysis of voice directivity. So this is kind of an example in the 2,500 hertz region. If you look at the directivity of the human voice as a function of vowel or phoneme, you get quite different patterns. So the idea is your simulation has to take that into account. So this is kind of giving an example between an A and an M. And you see kind of the side radiation being quite stronger for an A than for an M. But you can also find frequencies around 6 kilohertz where all of the sounds are kind of collapsing to the same directivity and there's less differentiation. So this is something that we're looking at now, how to integrate that into the simulations, and also what is the perceptual limits of how fine we have to model that, and also if we allow people to move. So in those examples, nothing is moving. But in current examples, if I'm doing, say, a simulation in this environment, every time I turn, I want to kind of correct for my voice directivity at the same time. Other things that we've been kind of paying attention to in kind of reconstructing complex environments, in addition to kind of movements, is the background noise. Because a lot of times when you do this simulation, you end up recreating this ideal environment where nothing else is happening, which gives you kind of a loss of perspective of dynamic range and naturalness. So if I wanted to recreate kind of this environment right now, I want to make sure to have the water cooler, because that's kind of giving you a real life reference of how loud things are and masking subtleties that you may hear in simulations, but you wouldn't hear naturally. So kind of an example that we have of that is on the theater project, was to film some actors that were doing a bit of a piece. So that's using a depth camera. So we have not a high resolution, so it's not kind of virtual avatars, but we don't have to worry about animation. And we get all of the natural movements and gestures, and to some degree facial expressions on the actors, and then so they can move around, and it's all taken into account in one recording. We can then extract the head orientation and position through the entire piece, and then actually have the voice simulation follow where that is in the model. And the first time we did that, and we were working with a group of theater historians, looking at how vocal usage and the room acoustics had changed, and they all complained that it felt like they were watching a rehearsal and not a performance, and they couldn't judge it in the right way. So then we had to go and create a whole audience in our simulation. So we kind of went for something somewhat simplified that was easier to animate. So this kind of wooden mannequin, giving animations where they could, scratch and cough and move around, and got into a lot of issues with how to randomize those kind of actions, because if 20 people all of a sudden start scratching simultaneously, it's a really weird feeling, or coughing. So we did a bunch of work on that. And the result is kind of this simulation, which was, I think it's now 10 years ago. So I think in this extract, it'll kind of bounce between about 3 positions in the theater while they're performing on stage. And then we also did kind of a scientific study on seeing how the voice directivity being included in the simulation impacted the perception. And the results were basically taking into account improved the plausibility of the rendering, the sense of natural distance to the actors, and the feeling of envelopment when all of that is correct. So this won't show changes in it, but it will show a bit when she's walking around. It's a bit dark, and the resolution is not great, but it was originally designed for an Oculus DK2. So everything is kind of tinted that way and simplified at that resolution of the time. And we'll see what happens.
Merde! Oh! Voilà du joli, Père Ubu. Vous êtes un fort grand voyou. Que ne vous assomme-je, Mère Ubu? Ce n'est pas moi, Père Ubu. C'est un autre qu'il faudrait assassiner. De par ma chandelle verte, je ne comprends pas. Comment, Père Ubu? Vous êtes content de votre sort? De par ma chandelle verte, certes merdre, oui madame, je suis content. On le serait à moins. Capitaine de dragon, officier de confiance du roi Wenceslas, décoré de l'aigle rouge de Pologne et ancien roi d'Aragon. Que voulez-vous de mieux?
Comment, Père Ubu?
Again, it doesn't render very well over this, but if you listen to it in binaural, you can really get the sense of while she's moving around and when she's turning and talking, that comes across quite well. So this was, let's say it was like 10-ish years ago, so that's at Connect 1. So we've been able to redo kind of similar things with the Connect 2 and multiple Connect 2, so you can get a much higher kind of graphic resolution. But at the time we were trying to get the theater historians to focus on the acoustics, not on the graphics. So it was kind of a middle road. Oops, I'm gonna do it again. There we go. So with those studies, which were mostly at least proof of concepts on modern day spaces, once we have confidence in the plausibility and the realism of the simulations, then we can start changing things and modifying the computer simulations to create lost acoustic conditions. And what that lets us do is either re-examine hypotheses from social science. So for example, there are hypotheses of what was the best acoustics for Gregorian chants at the time, and what was the impact of some decoration. And most of that research is coming out of literature kind of reading and reflecting, but not a lot of kind of experimentation. So this kind of lets us redo those or do new experiments to answer those questions, as well as to come up with new questions that sociologists had never even thought about, because they could never imagine being able to listen to kind of these different environments. So if I give a couple examples of kind of interdisciplinary projects, the first big one is looking at, if you give me an idea of time, I don't remember what time we started. I can go fast or slow. I'm realizing I've been talking rather.
You've been talking for about 30 minutes, I guess, that because we started late. So
Okay.
yeah.
So this is a historical building in the science of acoustics. So this is a semicircle lecture hall that has domed arches everywhere. And kind of the end of the 19th century, the acoustics was really bad. The president of the university contacted the physics department and said, "You're a young guy, smart guy, can you fix it?" And what that professor did was basically spent 3 years doing measurements in this room, trying to understand what was happening. And that was Wallace Sabine, who then invented room acoustics as a science out of that study. Sadly, though, he wasn't able to fix the acoustics. And so over several decades, the room was modified constantly in the hopes of trying to improve it. So this is the original, then they made it smaller, then they raised the podium, and then they even added a kind of a canopy in it. And then it was demolished in 1973. Pretty much. And I ran into this old architect who had actually got in there the day when the bulldozer showed up and did some measurements in the room right before the building got wiped out. And the idea was to kind of see, could we recreate the building that room acoustics was invented in, using kind of these procedures. So we can create a version of the room at the time when they did the measurements. We can look at their documentation, all of the photos they took and the measurements that they took to calibrate this room, and then work backwards to arrive at the original room that Sabine was in. So it's kind of a history of architecture and a history of science project. And the idea was to make that available to acoustic students. So you can try and figure out what happened, what it would have been like, what he was confronted with. And we found a lot of evidence of what he did. He went to court because he got sued because the acoustics wasn't good. He then countersued because it was because of the architect who wouldn't let him do the changes he would make that. But this was kind of an interesting historical study. The second one that we tried that on is the small cathedral. And that was mostly looking at what is the acoustics today, and then what was the acoustics in the 16th, 17th century, when it was still quite an active space. But at that time, kind of this whole choir area was enclosed with stalls and much more richly decorated with carpets and tapestries and things like that. And also it was a monastery. Is that right? Yeah, an abbey. So basically the monks sang for themselves. They didn't care what other people heard when they came to sing. And the result ended up, if we looked at the computer simulations, is that you have a much higher clarity and a very easy time singing in that choir space. But everything that's kind of public and the places that they didn't care about, the acoustics was quite bad. And that's quite a stark difference to what it is now when it's all open. So kind of a art history architecture study. This was the theater project, the reason why we did those simulations. And that was really looking at how the acoustics of this one famous theater in Paris changed over about 100 years, because it got renovated about every 20 years. And also looking at, because it's the origins, it's at the start of recordings. So they actually have recordings in the theater, not great recordings, but they can look at how the people's use of voice changed over history. And the question was, are people singing differently and speaking differently because of the acoustics, or because of the kind of other techniques in vocal usage and what was trending at the time? So a more of a performing arts study using simulations. This is the Palace of Trocadero, which was built at the World's Fair before the Eiffel Tower, kind of across the center from the Eiffel Tower. It had absolutely horrendous acoustics. It's this kind of big round space. And you're kind of before the emergence of a solid understanding of how room acoustics is working, but there are quite a number of notions and people inventing their own ideas. So the architect here tried to understand it in terms of echoes, and actually built this whole device as an echo detector, so it could send sound at a very specific directivity, and would have people in the audience, and you would raise your hand if you heard the echo. And the idea was to try to identify the different surfaces that were important. And then he tried to correct them. It still didn't work. So as in the other building in the mid-30s, they tore it down and built a new one. But through the simulations, we were able to not only simulate what the acoustics was, but also to reproduce his experimental tools and try to see really what was he finding, and also what was he missing, and why was his approach not working. And basically because he could only understand first order reflections, he couldn't understand second order reflections. And almost all of the problems in this room are second and third order because of the curvature of the spaces. So it was kind of interesting to see, to kind of understand why what they did didn't work. This is a project more of a kind of a digital humanities project. So this is a group of students that work in digital reconstruction of heritage spaces. And the school has a link with the Chateau de Versailles, and every year they do a different room and they try and recreate it. And this year is a collaboration. We got them to look at the Queen's Music Chamber, which was a room where chamber music was actually written for and performed in. And the idea was to kind of give a reconstruction of that. And I can give you a quick example. So all of the images reconstructed.
En effet, l'objectif de ce projet est de réaliser une simulation visuelle et auditive permettant à des musiciens baroques de vivre une expérience de jeu immersive dans un environnement réaliste, actuel ou historique, et de se permettre quelques libertés par rapport à l'histoire, en faisant résonner la musique du compositeur baroque Jean-Sébastien Bach dans ce salon, dans lequel il n'a pourtant jamais eu l'occasion de jouer.
that's all. Everything we're doing here is made for headphone listening. But it's just to kind of show how the simulation can have a
I
context.
have a question for the musicians. They
Yeah.
said like you made an quick recording. And are they anyway like fed the acoustics of the place that they be going to play for?
They were fed an acoustic, but not this one.
Okay,
They were actually recorded as part of another project.
okay,
So we kind of created what would be an average ideal acoustic.
okay.
So then they would have some reverb, but it wasn't on a specific space.
Okay.
But they weren't playing dry,
Right.
because that doesn't work very well.
Because I guess the musicians also like, especially for classical music, they tend to adjust like how they play according to the place that they're playing and what they.
Yeah, exactly. And this was, so this is a database that we made with 4 musicians. Playing, I mean, it's like 4 very different styles, from jazz to kind of this more chamber music. And there was a whole routine basically where they would play together in the acoustic that we were giving them for, I don't know, 15-20 minutes. That was recorded. And then they played one by one, hearing the recordings of the other 3 from the previous set, so that we could be sure to have a perfectly kind of isolated recording of each of them. But yeah, but that was not interactive with the acoustic that was being tested. Yeah.
En effet, le
So at the same time, as part of that simulation, we actually did studies with real musicians in a virtual acoustics and in the real acoustics, and had them play. I think we had 6 to 8 musicians playing historic instruments of the period. Currently, one of them had actually been played at Versailles. This woman had a very old Baroque instrument. And the idea was to recreate it in our kind of immersive environment and allow them to kind of play in both, and to see what the difference between this room was and a more 1960s chamber music performance hall of about 200 seats, I think, and see how the playing style differed between those 2. I think this is the last one that I have to present, which is kind of the biggest project recently, which has been on Notre-Dame. Everybody knows there was a big fire, roof fell in, and things like that. Originally, we were involved with the idea that we didn't know how they were going to restore it, and that we could use our computer simulations to help the architects evaluate a lot of proposals they were having. There were a lot of really crazy proposals of how it would be renovated. And then President Macron came out and said, no, we're going to build it the way it was before, which kind of took a lot of the guesswork and scariness out of what the future would be. So we were able to kind of turn our project upside down and say, well, let's look more at the history. And if we kind of look at the history of Notre-Dame, we have kind of, this is the building that was there before Notre-Dame was there, that was active, and it was torn down to make, this is how Notre-Dame first opened, while the construction was going on in the rest of the bit. Then the whole party opens, and then about 50 years later, they add all of these chapels on the side. So you have this kind of evolution over, I think, 200 and something years of this building, and it's coinciding with the evolution of polyphonic music, which is also coming out of kind of the school of Notre Dame singing, which is also attached to the cathedral. And so there were questions of what is the relationship between that singing style and the changing architecture? Because it's all happening at the same time. So we could say, is there an architecture for which this polyphonic music sounds the best? Or is there an architecture for which it's easiest to sing in? And the idea was to kind of evaluate that. So we've done a number of studies with recording choirs. That was a children's choir. We've also done 4 male choirs, and placing them in those different acoustics and singing music kind of monophonic music, so what was before polyphonic music, then polyphonic music, it was emerging, and then something from, I think, the 14th or 15th century to really have a variation and see how does their singing and interaction style change as a function of the acoustics. At the same time, yeah, I think we were also looking at intelligibility and how the changes in decoration and architecture affect sermon intelligibility, and how when we switch from Latin to French, how does that become important? And one of the other things is how does the acoustics change depending where you are in the cathedral? So this was a production that we did based on that same orchestra recording, where we actually reconstructed the whole piece, and you're on a magic carpet, and you can fly over the whole orchestra and through the cathedral and hear. The idea was to convey how the acoustics is a function of where you are during the cathedral. So. So this is just a number of the different ways we've tried to kind of share this research, mostly on the Notre-Dame with the public. So there was that one video that I just showed an excerpt of, so it's about a 5-minute video of the piece, is Ghost Orchestra, and that's on a 360 YouTube video, so you can hear it in binaural over the computer or over a smartphone. During COVID, for the anniversary of the fire, we decided to release the whole length version of that concert, but more as a radio production. So it's a web radio, because we didn't think people were going to sit with VR glasses on for an hour and a half. But you can actually listen to the entire concert at different places in the audience, and even I think the conductor's position. We had an installation at one of the science fairs, where we just had basically a quad system set up with 2 microphones, and basically just invited people to come in and sing in Notre-Dame and see what it was like. Julia headed that one, and that was pretty wild. So for 2-3 days, that was up and running, and it was from little kids coming to, some people who were, I would say, professional singer. One guy looked like he was a rapper and just started singing like he was in the children's choir, and it was quite good. So that was quite a fun experience. We've been trying some things at more organized or kind of higher quality productions. So the first one was the idea was to make a podcast radio fiction. And we contracted a company and basically said, you can create a story that uses all of our scientific output and kind of integrate all of our acoustics and musicological findings into a fiction that would be interesting to people. So they came out with Looking for Notre-Dame, or À la recherche de Notre-Dame, which is a fictional story about Victor Hugo, who's having writer's block while he's writing his cathedral novel, and has interactions with people, and basically is visited by a muse who takes him back in time to experience different acoustic events. And so that's a free 1-hour piece on Audible. And then right now we're in the ends of an audio guide production that focuses more really on conveying the actual results of the research and some historical elements And here it's more of a GPS guided audio tour around the outside of Notre Dame. And at each of the spots as you go around, you get some more information and some more historical elements. I think the idea is 16 pieces. 12,
18, well, the
12, right. There's 12 pieces plus 6 interviews with researchers. And that should be coming out in mid-April. And so that's free on Android and iOS. You can also, you don't have to be at Notre Dame to listen to it, but it's more fun if you're on site. Because there's a lot of references to what you see from the different spaces, positions. Let's see what's amazing. So the podcast is in English and French. The audio guide is in English, French, and Spanish. There you go. And then the latest one is a production that we're looking at for the end of the year, kind of with the reopening of Notre Dame. Very much music focused, is 11 pieces of music that are kind of tracing the kind of the musical history of Notre Dame and the acoustics of Notre Dame, where each piece of music is played in the corresponding acoustics over the course of an hour with a little interlude. And that's going to be kind of a web streaming and then also a virtual reality excerpt of about 10 minutes. I think that's it. That's a number of sites if you want to get some more information. I'm missing the one on the audio guide, which is Whispers ND, Past Has Ears. But yeah, so that should come out in mid-April. And then there's some of the publication in case anybody had a question where all that's coming from. But there you go.
Thank you.
If you have questions or more questions or lots of questions, thoughts, things that you want to do, you can also make it an open table of how would you use this kind of ideas in your own research.
So I guess that the public and or the authorities in Paris, for example, with this Notre-Dame, are very interested in this type of research, or how have you found the reception of this research?
Well, it's hard to say. It's hard to know how to judge that. If I judge it on interviews, because we're part of the acoustic scientific committee on the restoration. So we kind of get contacted by the press for things. Most of the press that calls us is not French. I've done more interviews for the Germans, for Spanish, for Italians, Canadians, Swiss. I think at the moment, the French are much more focused on the building, and the acoustics is kind of a side thing. We're very much hoping that the audio guide, and once it's no longer a question of is it going to fall down, and what it will look like, that there'll be a lot more interest that way.
I'm sure it will raise a lot of interest, because everything that has to do with the senses is very much raises a lot of interest by the general public. So
yeah,
I would expect it to be.
I'm hoping, and the fact that we can, we're presenting not just the acoustics today, but kind of over 800-900 years, and I think it's the only real research examples that are able to do that. I mean, a lot of the other visual reconstructions don't do it in the same way, and once it reopens, I think there'll be even less interest in how it was before. But the idea is that the audio guide should run for 5 years minimum. And we'll see who pays for it afterwards.
try to open because there are some comments and because we stopped
Sure.
people from using, let's see whether I can allow them to talk.
Or you can read the comments, or
I can read.
you want me to stop sharing and put that up, or?
Yes, perhaps.
Let's that, and-
Eva Sandgren said, thanks for a very interesting presentation. Unfortunately, I will have to leave. I have been PI in a similar but a smaller project on medieval Swedish site of Vadstena Abbey, where we recreated the church of 1470 and its soundscape. Yet there is no much written in English, but I'd like to share some links with you. The publication on the project will come up this year on Sketchfab and YouTube. What you can see in these links are preliminary versions. The results will be presented to visitors in Vadstena as well. And that was Eva Sandgren. Yeah, it's just and then Camille Kopic says, sorry, no camera, and I can't really share my mic right now. Thanks for a great presentation. I'd like to ask if you published your results of the studies on fidelity and immersive VR versus real thing.
Yes.
See whether I can call.
The left?
No, I think it's this one.
I think Camille, you might be able to.
It's
see
the
them.
second one there. I think I don't have, we turned off the highlighter, so I can't write on.
So second one.
Oh, there we go.
I don't see.
I understand why you want to screen at home.
Maybe it's not one of these. I want one of these. So that was the study actually comparing the perceptual difference between the simulated and the real acoustic.
Camille says, thanks a lot, I'll check it out. And Eva has sent also the links, but I don't know how to share this with everybody. Perhaps if you could the chat comments.
Oh, no,
Oh, don't do that.
descarta.
This guy.
Okay. That one. That one.
And there, and then.
Last,
Last, yeah, chat. Yeah, so you can see there, some, and I'll copy them and we'll check.
I have a question.
I was.
Good.
But it's, I don't know, like it's, I just want to know your opinion also, like it's like, I guess, I don't know, you call it like philosophical, like that's one thing. Many of the important buildings or like what they consider as monuments right now, they went through changes over the centuries, depending on the needs, like of that century, like they did extensions, like they changed things. Sometimes they were like war, fire, etc. But there was actually less, I couldn't call it necessity, but interest in like keeping things as is, but they kind of like evolved over time, like and became what they are now. And I mean, I always thought that's like they tried to keep the acoustics of Notre-Dame the same. I kind of like, it was a nice thing for me, especially working in the field of acoustics. I said like, okay, like it's interesting that they have like give importance to this and like someone working on this and like they're showing an effort. It's nice because normally it's just like discarded in like some other cases. But also now, like seeing your presentation, I also like, I don't know, suddenly it came like we also like lost an opportunity to like evolve and like go further. And like, I mean, like further is might not be the same word, but like just do something that's like more like depending on our times, but still looking like anthropologically back to like what it was and still make something like even like, I don't know, like further out of it, like rather than just like sticking, no, we're just going to do it exactly as is, which is sounds like a little more nostalgic and
well, the as it was I mean, that was kind of the big part of what our research was. As it was, includes a lot of things.
Yeah.
I mean, when they say as it was, they mean the day before the fire.
Yeah, this is what I thought.
So-
But it's also like it's an opportunity to like maybe if we weren't in such a rush to reconstruct it, we could actually have like open conversation and it's like, so what do we do with this? Because most of the important buildings, their construction went on through like centuries, and it wasn't just like something that okay, like let's do it as fast as possible. But like it was like the evolution of that building. And then like I find like now like I feel like we missed an opportunity like to do something. Like they could have like proposed something that okay, like times have changed, and also like this is also like a big monument, like we could do something while like looking at the like past that it was, but also looking at the future rather than like let's build it like as it was yesterday.
Yeah. So we've been so the idea was this whole study on how the acoustics change over the centuries
Mhm.
was a way to start that discussion.
Ah.
The way that the building is being reconstructed, there's the architectural stone elements
Mhm.
by the state, and then it gets handed back to the cathedral to you as a user.
Mhm.
Which means everything that's decorations is in the later part.
Mm.
So our idea was, well, if you're not changing the stone and you're not changing the form of the vaults, because I mean there were proposals of a glass ceiling and things like that.
Mhm.
So the idea now is to get more into discussions with the people who run the building and say, well, this is how the acoustics has changed. This is how it affects singing. This is how it affects, preaching.
Mhm.
Where do you want to be in kind of that acoustics for the uses that you have now? So I've already had a couple discussions with the head of the choir and the music and the cathedral, kind of looking at that. The idea that before it reopens, we want to get back in and do some measurements and
Mhm.
already be able to compare before and after the fire. Because we're expecting it to be more reverberant now than it was before, with
Mhm.
all of the plaster and the painting being kind of cleaned and redone.
Mhm.
So then we can talk and they're also expecting much more visitors and much louder visitors, because they're all coming to see the reconstruction, they're not coming to pray. And how to mitigate kind of all these extra noises that are going to be coming in.
Mhm.
So those two things I think will be part of kind of this year, well, the later half of this year and then into the following year discussions on what can we do with the acoustics
Mhm.
to help them with their uses. And I think it's more on they are more interested on the preaching side, but definitely the background noise side than the music side. Because from their point of view, when Notre-Dame was an active cathedral, you had a choir of 50 or 100 normally. Now they have 10. So they say, we don't care about the acoustics, we want a new sound system. So there's a big effort to rebuild the sound system that they have with very directional speakers to kind of get the benefits of a good acoustics, but through electroacoustics. So it's all phased arrays and things like that. So that's their solution, knowing that the second they leave the primary singing position, it doesn't work anymore. So if all of a sudden the singers start moving around or at the organ side or are walking, that whole system kind of falls apart. And the issue is for them to come to grips and the realization of how it can and can't be used. But yeah, it's kind of the electroacoustic solution to that. The other is the choir organ. So the grand organ is a classified monument. It wasn't damaged, it was just dusty. So it's being cleaned and then put back in. So there's nothing with that. The choir organ is not a historic monument, and it got totally destroyed by kind of water damage. And they're very much looking at what do we want the new organ to be and to better represent the use of the organ. So before it's in the choir, don't have that. You kind of have the choir, and right, historically, kind of the choir organ is there, pointed that way, which is great when it was originally put there because it's put there for the people that are here singing, so they have some accompaniment. But here it sounds horrible. So at the moment, they actually have speakers that have mic'd that organ, that they turn it down, and hopefully you can't tell that it's coming from that. But it's totally poorly suited to today's use, which is concerts and the general public. So they're looking at expanding the organ because it was quite small, almost doubling it in size, and also thinking about where could they put it differently to better project into the rest of the hall. So we evaluated, I think, 3 proposals from the competition for the organ builders, and put those into the acoustic model to see how each of those would address kind of the new needs of the cathedral. So they are thinking in terms of that, but that's on the cathedral side, not on the reconstruction side. And it's a very strange kind of divide between the two. But I think those things will happen once the building gets handed back over to the cathedral. And you can go in and you can listen, and then you can say, oh, we need to fix it. And we're at least hoping to be able to be there to kind of help them in that direction. I mean, I've been thinking about variable acoustics. We could actually bring in, the 14th century acoustics with, banners or things like that. They could be very well done visually to represent what the historical kind of tapestries were at the time. And I think that would be more interesting than if they came in and carpeted the place, which is what they did in the 90s, when all of a sudden there was too much noise from the public. They just put a carpet, and there was a carpet in there that we can have measurements before and after the carpet, and we can see what the effect is. But it's a pretty ugly solution, and not at all kind of integrated into any kind of historical context. So I think that's kind of the next phase, is because we're not changing the form or the construction material. It's now into decorations, and I think that's where we're hoping to be much more involved in the next phase.
And it's kind of a shame because as you showed the example of like Sabine, also like there are some things that are very much depending on the architectural part. It's much more difficult to later on come in and to take an acoustician and say like solve it. And then they're like, oh, too late.
I mean, I think in at least in the context of Notre-Dame Cathedral, the acoustic difficulties, you'd have to tear the building down. I mean, it's not the things that make it, the things that are unique in how the acoustics moves in that space. To fix it, you'd have to rip out the triform, and I mean that's just crazy. So it's really about the decorations to correct. There's no like focusing effects or weird domes or things like that. It's the fact that the transept is huge and sound on one side doesn't make it very well to across it.
I think that Lydia had a question. Perhaps you can put your camera on.
Hello, everyone. Hi. Yeah, I have a couple of questions. Thank you first for this very nice presentation, Ryan.
The other people.
Yeah, the first thing going at the by the beginning of your presentation, I'm curious about the experience you have had with the, this impedance scan to measure the textiles in the Louvre.
Not a good experience.
That's why I'm asking that, because I tried to use that a few years ago and it was very difficult to get reliable results.
Yeah, so we did, we did a lot of measurements with it, and then we did some comparative measurements between that system and kind of more traditional methods. So Julien was working on that. So, I mean, we took one of the velour curtains from the museum that they let us have for a couple weeks, and measured it in our anechoic room. Took it to a testing lab where they measured it in like an impedance tube. And
A reverb chamber.
a reverb chamber. So we were trying all the kind of classical measurements. And right now still kind of going through the data of how similar are they? And if there's issues with that impedance probe, is there any way to correct it after the fact? And that's where we are at the moment. At the moment, I'm not very happy about it because there are things that we only measured with the impedance probe, like in the Louvre, that it's kind of a lost opportunity if we can't recover the data. But at the moment, it doesn't seem easy. And it seems quite unstable. But I'm hoping that if we kind of put our heads down, we can figure something out about it.
Oh, it would be great to hear about that when you finish.
That's the most positive I can be on a very depressing.
Yeah, I understand. A second question was, in one of the pictures, I saw you took recordings in the anechoic chamber of the singers with a Celia microphone.
Yeah.
Am I right?
It was one of the microphones. Yeah, I mean each one had a head-worn microphone. So they had individual microphones, plus we put a Zelia in to kind of as a backup. I can't remember if the Zelia was what was used maybe in the audio guide piece or
no. I was just curious how do you integrate, how do you use this spatial recording in the
we were looking for different ways to get a better isolation of each singer, to have different tracks for each singer. So we have individual mics, but there's some kind of crosstalk.
I see.
In them. And we thought the Zelia would be the ambisonic mic is another alternative where you could do a beamformer of each one. But I think the head-worn mics work so well that we haven't used the Zelia microphone. So right now it's kind of, I guess it's more unused if you can use it.
Well, we ended up using the individual mic.
Nice, interesting. And the last one for my side. In the simulation where in which you integrate this voice directivity of the source for the theater one, do you use a self-developed software to do that, or you integrate that in a commercial software?
So we published it a couple of years ago. So we made a plugin that lets you decompose a source into a number of independent directions. So imagine instead of if you have a dodecahedron source, if each speaker is perfect and only sends sound in its direction, then you do a computer simulation for each of those speakers, and then in changing the level of each of those speakers, you can create a directivity pattern. So we have a plugin that does that. So we've done it, I think, with 12. We did one. The first example for the theater was with 12 different directions, and then the latest version is 20 directions. So you can have quite an accurate reconstruction of the directivity pattern.
Great. So I understand. The idea of using ambisonics is similar to the loudspeaker we have in the project, the MIMO loudspeaker.
Oh, it's not sharing anymore. Okay. But yeah, so well, it's too confusing. So if you look at the third reference on the list, yeah, so there's we presented that as a plugin, and that I don't know if we have a website for it now that I think about it. But yeah, that's something that
I will have a look.
That we can share quite easily. it's a VST plugin that you use with, right now we use it with basically a set of simulations that you run in Katz, with kind of a predefined directional source that's optimized.
Thank you very much.
So yeah,
back to the real
yes,
people.
So there's something I sometimes wondered about, and I think that this is a perfect space to ask this question. So I was wondering how much these sacred spaces like churches or the rocks or the caves were intentionally created with a specific form to enhance certain acoustic experiences, or how much these experiences are like a side product of the form. So it's like a chicken and egg problem, right? Like it's like, would the people who like the cavemen, were they like checking the cave and asking, oh, this cave looks nice, but I don't like the acoustics because we cannot make our like event here, or was it the other way around? Yeah, I don't know. Just I always wondered how much.
I mean, on our side, if there's no documentation of someone saying it, it's very hard to attribute intention. I mean, they did. I mean, like with Notre-Dame, there's a lot of writing about what Gothic architecture was meant to do, and acoustics wasn't one of them. I mean, it's kind of a byproduct or analogies that if you really push it, you can kind of imagine. But the understanding of kind of how acoustics work, I have a hard time saying they did it because, rather than saying, ooh, it was like this and look what they could do with it. So that's one of the interesting questions I think about the polyphonic music is, did it come out because they all of a sudden had a performing space that it worked? Like if you tried to sing the same way in the building it was before, was it harder? And it's only because of the new building that they said, oh, now we can actually hear each other in a way that we're able to sing this new style. And things like that also evolve faster. I mean, not so much in rock art, but it's a cathedral. It takes 200 years from when they started building it to when it was mostly finished. You know, any kind of human cultural style evolves much faster than that. So it's much easier for me to imagine the culture adapting to the architecture than the other way around. I think cave art's a bit different.
Yeah.
But kind of the similarity between, I mean, I know there's studies on, there's great acoustics every place there's a big drawing. Well, yeah, but it's also the big drawing is on the big place, which is in a big cavern. That's the acoustics you get if
right. Exactly.
There's no ugly cavern like that. So is it more of a byproduct?
Yeah. I mean, and we are in a worse position than people who are working in medieval or post-medieval times, because we don't know the music. We have no idea of the melody, how we might know about some instruments, but we don't know how they were played or in what occasions really. So what we are looking is at patterns. So if in a place with landscape with rock art, we have places that have been painted and some others that haven't, are the acoustics telling us that they were selecting the places? But what they were doing there, we will never know. We can say this place has very good reverberation or not. So we can say this place would be good for that, for this particular reason. But we cannot go much beyond that. And we are looking for patterns. So it's not enough that the space is fantastically, or that the reverberation is fantastic in a particular painting in a cave or no, because one is not, doesn't tell me anything, can be just by chance. So I'm looking for patterns. But of course we are in a worse position then, you know.
Yes.
But you get to go to different places.
Yeah, we have a nice time going to places.
But yeah, that kind of, I mean, there's some things that I think are naturally, at least you notice, like an echo and a focusing. And then you can say, well, you know, were things chosen because they had.
Actually, do we have groups of, let's say, architectural changes in those caves
No.
done by them?
They
They
were-
just, they were leaving there.
No,
They
they were
changed.
modifications at that time. We are talking here about hunter-gatherers and early agriculturalists, so they were not interested. And in fact, in most places, I would say that the acoustics were not key for them. The reason for that, I was explaining before, and I've mentioned this in a couple of talks, is that in fact, what you want in a group, when you're in a small group, and you sing together, you do things together, it is that sort of community things that works really well in order to make groups for, you know, to create that sense of group. When you have, so we are talking about a small group, so the acoustics might be important in some cases, but in most or in many cases is not essential. It could be important for communication purposes, because you don't have the speakers, so you really need, even if, you know, when hunter-gatherers get together in an aggregation site and you have a large group, you really need to be able to communicate what you were saying if you have everybody there together. So we are not talking here about 20 people, but perhaps 200 or 100, and then we need to be able to communicate. But once you go into state societies, that you have large numbers of people, and you start having constructions, then I think that's when acoustics start to be important, because you control emotion. And once you are controlling emotion, but you can control it in many different ways. So there's no one solution, in the same way that acoustics is not the same in a church, and it hasn't been, I mean, there have been changes throughout time, but it's not the same a mosque or a synagogue or a church or a Buddhist temple. Everyone is using acoustics in a different way. And even that changes throughout time.
I mean, we were looking at how the situation changed when the preaching shifted from Latin, which is only spoken by the clergy, to the local language. And all of a sudden now it became important for those hundreds of people to actually understand what you're saying. Well, now you can't have the preacher all the way at the end anymore in his little golden area. You have to move it into the middle of the people, because the acoustics doesn't let it be intelligible if you're too far away. And you can kind of compare how intelligible it was depending on where you are. And it's like, well, that's why the podium is stuck where it is so that you could actually hear what's being said. So you can imagine the same thing in caves, where you're not necessarily looking for kind of religious, spiritual echoes, but you're looking for, I want to talk and I want everybody to be able to hear me. So the choice of acoustic can also be very different from the.
I mean, I never thought about this like before, like until like even if the ceremonies like took place, like especially in like semi-open places, if the ceremonies took place during the night or during the day, they have like different acoustics, like it would affect on the happen.
The fact is that we don't know.
Yeah, exactly. Like, we don't know, like when do we start playing music?
The oldest, Upper Paleolithic, the oldest instruments that we have are dated in the Upper Paleolithic, but perhaps Joshua, once you want to explain about this, you might know more. I mean, the oldest, I will say this and then we can add. The oldest musical instruments are the flutes that have been found in Germany, in caves. There might be others, but you know, research in Europe is much more developed than in other parts of the world, and because it was very cold, people were doing many things in caves, and so preservation is better. But those working in human evolution say that music came probably at the same time that language, and the evolution is with Homo. So it can be very old, but we don't have any evidence because it's sort of bones and so on. But they are part of the brain that so this Broca area that is reflected in the cranium, in the skull, that then says that language is very old in Homo. But you know, it's sort of secondary evidence of what we have. Musical instruments per se is 40,000 in this Bielefelds and what's the name of the other one? Gloucester, something in Germany.
But that's limited, but that's bone because bone survived, right?
Because
I mean,
it
if it was
survives.
but if it was a tree trunk that you made a
Yeah.
drum out of,
Yeah, exactly.
there'd be no trace of it anymore. So
Yeah.
it's
I mean, vocal music, because at the end of the day, the voice is an instrument, but so it could have started much earlier. And that's what people working in human evolution say, that language and music may come at the same time, that we're sort of parallel. Some people say first language, other one says first music is probably both at the same time.
Danny has a question. Danny, can you check if you can activate audio?
Yeah, I think I can, right?
Yeah, great. So perhaps you can put the camera on if you want to. Go ahead.
No, I actually I can't. I don't know why, but I'm not allowed to like use my camera.
Okay.
But well, in any case, thank you, Ryan, for such an inspiring presentation. And I would like to know, in regards to the simulations at Notre-Dame, how do you actually do it? Because I assume that, I mean, the performers are the same, but when you record in the cathedral, did you guys do it in mono, in stereo, with a particular microphone configuration, and then you replicate it in the anechoic chamber? I mean, how do you manage to preserve like the right or the same configuration in such different places?
So for the orchestra performance, I think that's the one that you mean. That had close mics on all of the music sections over the entire cathedral. So there's 45 microphones kind of spread out everywhere, capturing what each one is doing. And then in the computer simulations, for each of those recordings, we create an acoustic source in the model at the right position with a directivity of that instrument section.
Okay. But then when you recorded the audio, because I guess the audio was recorded as well, right? In an anechoic chamber?
So then it's the audio then gets fed into the impulse response of that musical instrument at that position in the model.
All right. And when you recorded it in the anechoic chamber, you use like approximately the same
So the
distance.
anechoic chamber it's kind of a different use. That's looking really at recreating the acoustics for the musicians in the anechoic room while they're playing. So for that, for example, with the four singers, we do a simulation in Notre-Dame of the four singers where they would be standing with the directivity of the voice for each of them. We simulate the acoustic conditions of each of them separately, which is then used with the real feed from their microphones. That's then played back to them over headphones.
Okay. And the result in both cases is in stereo or in mono?
We do mostly binaural.
Okay.
But it could also be we usually do either ambisonics or binaural.
Okay, I see.
If like for the singers, because there's 4 of them all simultaneously, it's kind of too computationally intensive to do ambisonics for each of them. And also they don't move that much, so head rotation from the singers isn't that important. So in that instance, it's in binaural. In the orchestra recording where you're flying around, it's all in 3rd order ambisonics. That then gets transformed to binaural when you listen to it.
Okay.
As a function of, like on the player, like the YouTube player does its own conversion from ambisonics to binaural, depending on where you're looking. So those are kind of the 2 extremes, but to do something in real time, we've only really done the ambisonics when it's 1 musician, not for 4.
All right. And this was done, I assume, not before the fire, right?
Yeah. The concert was recorded, I think, in 2013.
Okay.
It was for the 850th anniversary of Notre-Dame concert.
All right. And just out of curiosity, where was the conductor's position or location in the cathedral?
Just off of the transept. If you look online and you look for the Ghost Orchestra Notre-Dame, we have a whole web page that kind of breaks down all the technical aspects of how it was done, how many weeks the simulations took. There's a good presentation on that.
Okay. All right. I'll check it out. Thank you so much.
Yeah.
I have a question about the music project. You said that you put like some musicians inside of a virtual environment to recreate the acoustics of the room. I'm curious about what was their feedback as musicians to be playing in this virtual environment compared to the reality. And let's see if there was any different due to the fact that they were exposed to these visuals in front of them. Change the visual or turn off the visual.
No, they had nothing. Oh, in the Versailles one.
Yes.
The Versailles one was one of the first interactive ones that we did. And while we usually I prefer to use headphones, because I think you get a better quality and less chance of feedback. Some of the instruments don't work with headphones. The same way we couldn't use virtual reality glasses because they couldn't see the sheet music anymore. So we went for a speaker installation and the projection. And the biggest problem we had was that we ended up getting some feedback between the recording microphone and the reverberation for some of the instruments. Basically, we tested it with voice and we sang and it was fine. And then the flute came in and went and got a very bad feedback, so we had to turn it down.
Because of the screen.
No, because it's the
speaker and
the speakers on the microphone, and we had it just at the limit of where it was okay, and then because you had to mic the flute closer, and because it plays so much louder, it made a feedback. So they started complaining about the coloration of the system, and it took us a little while to figure out what that was. But I think the other instruments that weren't in that situation said it sounded very natural and comparable to how it had been. We didn't get to the next phase, which was starting to swap acoustics and visual, because that's the kind of the advantage of the virtual space, is I can give you the acoustics of the Versailles and the visuals of the modern concert hall and back and forth. So I think that's still in a next stage to see how much are the musicians basing their impression on what they see.
we need to leave this room in 15 minutes. So I don't know whether you have any other questions.
It's been quiet over there.
Yeah. Right, Raquel was saying, Raquel, could you see whether you can now use your mic?
I want to put up a whole page of questions.
Yes, exactly. That's why I'm saying if Raquel is able to do it. Can you do that? Right. Perhaps she's in a place where she says, thank you very much. Thank you for the presentation. Unfortunately, I can't use my mic as I am in the shared office here. My background in psychology, my background is in psychology, so I'm intrigued by the potential application of your research in my field. I recall attending a congress on sounds in intensive care units, where there was a discussion about making machine-related sounds less traumatic for the hospitalized individuals by transforming these sounds into more soothing ones, like piano keys. Your research somehow reminded me of this. I can imagine that when confined to spaces, it must be beneficial to immerse oneself, even if virtually, in the environment of cultural significance and openness, or at least the spaces that are more open than hospital rooms. Do you know of any applications of your research in this context? If not, I think it would be an interesting thing to test.
Well, it covers a lot of things, doesn't it? I mean, the equipment that's all beeping isn't for you. It's for the medical staff, right? I mean, it's not for the patient to hear the beeping.
Yeah.
It's for the nurses and the doctors to hear the beeping.
Yeah, but the patient could.
Yeah, so I mean, already just to be able to wear headphones and go somewhere else. I mean, I know there's been work on redesigning all of the.
I'm sorry.
We should talk.
Yes, I know, but the guy have like a.
Sure. We'll figure something.
We'll figure something out. But it's okay. Thank you for.
Thanks for coming.
I don't want to interrupt.
I mean, I know there was already like a big push to redesign the instruments, because I think they did a study that the loudest annoying instrument was the least significant thing that we're measuring at the moment. And that there should be some readjustment to what's important and how loud and how distracting all of the different instruments are. And when we did go on a competition with an architect to make a relaxing space in a hospital. So there would be a corner where basically patients who can't leave can go and pretend to be like on a beach or in a very open space using that kind of virtual reconstruction. So there's definitely, in terms of relaxation, there's a way to do that.
Right. I think that
only three who haven't talked.
I mean, I'm more interested in like technical stuff, like maybe more of the also the visual side, like you mentioned game engines that you do for simulations. I'm thinking about the possibilities of how the will work, you know, like WYs or all of that. Have you thought about maybe how would you be able to
so we're
somehow
using,
for like more like real-time applications instead of simulations and all that?
I mean, right now, I mean, we're using Unity mostly. We used to be using we used to use Blender game engine, but it doesn't exist anymore. So we've been using Unity and communicating between Unity and an audio engine, an external audio engine, so Max MSP or something like that. When we want high quality rendering, so then you have kind of the two running in parallel, and they can talk back and forth. If you have to do it self-contained in the game engine, then things become much more limited. Than, you need to pick. I mean, there's a number of different middleware. It kind of depends what really you want to do. I mean, we've been doing a lot on the Quest now. So trying to find a way to get kind of ambisonic audio into a Quest. We haven't used the microphone yet, so it's not interactive. But not using wires, but using some other ways. So we have third order ambisonic simulation, well, playback. So basically you create a movie and then you can play it back. But there you can use third order ambisonics on the Quest with the head tracking built in. And we've had pretty good success with that. So that's quite doable. But we haven't at all tried getting a microphone involved in that situation. And those it's better to have something that's high performing and dedicated. Then you can there's no reason to try to integrate the audio into the game engine when you're running on a desktop machine, when you can actually have a higher performing audio rendering engine and the communication is pretty simple.
I can imagine this.
I'll say pretty simple.
The audio engines and all of that, I mean, are more always like complementary to the visual, usually like industry and gaming and all of that. I mean, sound is more like always.
I mean, I think there are the tools that are in there, and Wise lets you do some things, and DRVR lets you do some other, but they're kind of limited in ways that we prefer to have kind of our own tools and know what it's doing and be able to update and modify quite quickly. And so it's just easier. The game engine says you're here, you're looking that way, and you're in state 3, and then the audio engine just matches them.
I think we should probably stop here. We've been almost 2 hours.
Sure.
2 hours here, so I guess it's time. So thank you very much for this fantastic talk and this fantastic discussion. And anyway, so let's see whether how all this takes us in the future. So thank you very much. And